Good morning, viewers. This is Kasturi Day. Today I'm back with the Mendelev's periodic law. This is the previous chapter which I was continuing. That is the periodic table according to ICSE syllabus class 9. Okay. So I will start with today with Mendelev's periodic law. And before that, I will request you to please to subscribe my channel if you have not subscribed yet or you are a new viewer to my channel, and also ring the notification bell so that it will notify you as soon as a new video is uploaded. Okay, and please to like the video if you are liking it. If you are liking the videos, press the like button, share with your friends so that they can also be benefited from these videos, and also do meditate before you start your day. Okay. So before we start, we will concentrate on a point of light for meditation for just 1 minute. So please do join with me. Please concentrate on a point of light. Think that light is falling on you, lighting you up. Your whole body is lighting up. You're feeling energetic, feeling calm. Feeling interest in your life. Or whatever job you're doing, you're feeling happy, you're doing your job very willingly and happily. Thanking God for giving you such good blessings so that you can enjoy your work, maybe studies or any other job that you do. And you're feeling very comfortable. Okay. And here and start with the today's discussion. Okay. So as I was telling you that we will start with Mendelev's periodic law today. Before that, I will tell you that in my last video, I was telling you about this one, Newland's law of waves, then the law of triads, okay? And then why they were discarded and why Mendelev's law will start. It was periodic law was accepted, okay? So we will start with that. So first is that Dmitry Mendeleev, he was a Russian chemist. He published a periodic table in 1869, 5 years, which was 5 years after John Newlands proposed his law of octaves. After he proposed, 5 years later, after Newlands proposed, 5 years later, this Mendeleev, he proposed the periodic table. He published a periodic table in 1869. What did Mendeleev do? He also arranged the elements which were known at that time in order of their relative atomic mass. But he recognized that the physical and the chemical properties of the elements were periodically related to their atomic masses. He found that the physical and chemical properties of the elements, they were related to their atomic masses. And so he arranged them in his table in such a way that the groups of the elements with similar properties fell in the vertical columns. So he arranged all the elements which were having the same physical or chemical properties which were related to their atomic masses. They were grouped in vertical columns, similar vertical columns. Okay, like germanium, scandium, and gallium were not included during in his table in Mendelev's table. Why? Because they were not known at that time. Okay, his periodic law states that the properties of elements are periodic function of their atomic masses, meaning that when the elements are arranged in increasing order of their atomic mass, the physical properties and the chemical properties of the elements of the periodic table will repeat themselves in a periodic manner. His law states, what did his law state? That the properties of the elements are a periodic function of their atomic mass. Okay. These properties of the elements, they were the periodic function of their atomic mass, meaning what? That when the elements are arranged in the increasing order of their atomic masses, that is, the atomic mass increases in that way when they were arranged, the physical and the chemical properties of the elements of the periodic table will repeat themselves in a periodic manner. One after the other, in the periodic manner, they will repeat itself. Okay, these properties will repeat themselves. Okay, the elements were arranged in the increasing order of their atomic masses. Okay, so the elements, but they were arranged in the increasing order of their atomic masses in a form of a table that was referred to as the periodic table by Mendeleev. Okay, so the elements that seem to possess similar properties were grouped in vertical rows, which were known as columns, and it contained 7 horizontal rows and 8 vertical columns. The horizontal rows were known as periods. Horizontal rows were periods and vertical rows were columns. Similar properties grouped in vertical columns. Okay. 7 horizontal rows, that is 7 periods and 8 columns. Okay. 8 groups rather. 7 periods and 8 groups. Okay. In Mendelev's table. Then the periodic table is a chart. What is a periodic table? It's a chart which is used in chemistry showing the chemical elements in order of their atomic number. Okay. So the periodic table, it looked like this one. Mendelev's table, it looked like this one. The periodic table is the chart. It's a chart of chemical elements. Okay. It's in chemistry subject only. So it's a chart of chemical elements which were arranged in the order of their atomic numbers. It is so called. Why it is called a periodic table? Because of its periodicity among its elements. And because of the way the elements are arranged. The periodicity of the elements and how they are arranged in the way they are arranged. That's why it is known as periodic table. The horizontal rows going from left to right are called periods. I told you horizontal rows from left to right, they are called periods, and from going up to down, they are moving up to down, the columns, they are known as groups. Okay. Now, what are the essential features that were found in Mendelev's table, periodic table? There are 8 vertical columns which were known as groups, and they were numbered from 1 to 8. Okay, so there were eight vertical columns known as groups, and they were numbered from 1 to 8. Groups 1 to 8 were further subdivided into subgroups, 2 subgroups A and B. Okay, group 8 had no subgroups. Why? Because inert gases were not known at that time. They were not discovered at that time. So that was the 8 subgroup was not subdivided. Now all the elements of the subgroup or of group 8, which has no subgroup, have similar properties. All the groups, that is the vertical columns, they all had all the subgroups or the group 8, which has no subgroup. Those all elements, they had similar properties. They have similar properties and they show same valency, which is equal to the group number, that is 8. Group number for up to group 6. Okay, so till group 6, the valency were the same as per the group number. And not group 6, till group 4. Okay, till group 4, they were the valency will be equal to that of the number of the group number, that is. But after 4, that is from 5 to 8, okay, that the group number was subtracted from 8. Group number was subtracted from 8, and that will be the valency of that element of the group. There are 7 horizontal rows known as periods, and they are numbered from 1 to 7. As one moves from left to right is a period, and that is a gradual change from metallic to non-metallic properties. So that means the horizontal rows were 7 horizontal rows known as periods, and when one moves from left to right, the elements gradually change from metallic characters to non-metallic characters. Okay. So this was the periodic table, which was based on Mendeley's periodic law. Okay. So see the picture here. These total blue colored boxes, they were known to Mendeleev. Okay. But the blue colored with white checks, they were known as Dobener's triads. Okay, like lithium, sodium, potassium, calcium, then here chlorine, then sulfur, then strontium. See, lithium, sodium, potassium, they were triads, Dobiner triads. Then calcium, strontium, barium, they're also Dobener's triads. Then sulfur, selenium, selenium, these are also Dobiner triads. Then chlorine, bromine, and iodine, they were also Dobiner triads. Okay, but these blue colored, they were known as, they were known to Mendeleev. The yellow dots, that is LA, these are lanthanide series, AC actinide series, and known to ancient, the red dots, that is carbon, sulfur, iron, copper, silver, gold, then mercury, strontium, then lead. These all were known to the ancient persons also. Okay, that's why these are red colored. Now, this is the actual Mendeleev's table, which he prepared. See, you can see from here. See, there are eight groups. Okay, 1, 2, 3, 4, 5, 6, 7, and 8 groups. Now, these 8 groups till 7th group all were subdivided into A and B groups. Okay, A, B, you can see. But 8th group is not A and B group subdivided, because here the inert gases were not discovered at that time. That's why these are not known. Okay, all right. Now, yes, the group A of subgroup A of group 1 will contain hydrogen, lithium, potassium, rubidium, cesium. Okay, and group B contains sodium, copper, silver, gold. Okay, like that, these all have groups of they are subdivided into A and B. There are, you can see 6 groups, 6 periods are there. 1, 2, 3, 4, 5, and 6. Even 7 is also there, but 7 it's not showing here. So 6 groups 6 periods we can see, and when as per Mendeleev's periodic table, when we move from group 1 to group 8, in all the periods, when we move from group 1 to group 8, the metallic character changes to non-metallic characters. That is, from left to right, if we move, the metallic characters of the elements changes to non-metallic characters gradually. Okay. Now, what are the merits of Mendeleev's periodic table? First is grouping of the elements. Okay, advantage of the Mendeleev's table, periodic table is grouping of elements. Mendeleev was the first to successfully classify all known elements by generalizing the study of these elements to the study of mere 8 groups. He was the first one who classified all the known elements of that time by generalizing the study of these elements to the study of mere 8 groups. 8 groups, by making 8 groups, he arranged these elements successfully, classified them successfully. Now, gaps of undiscovered elements. He kept some spaces, vacant spaces in his periodic table, so that he can fit the later on discovered elements, which were not yet discovered. The elements which were not yet discovered at that time could be fit into these gaps, okay, in the vertical columns or groups. Okay. Now, prediction of properties of undiscovered elements. Mendeleev predicted the properties of these elements even before they were discovered, which were later found to be correct. He predicted the properties of the unknown elements at that time, and he was found later to be correct. Okay, the properties and existence of 3 elements were predicted, which was similar to the properties of boron, aluminium, and silicon. Which were those? The new elements predicted were isolated as scandium, gallium, and germanium. They were initially named as Eka-boron, Eka-aluminium, and Eka-silicon, respectively, because their characters were very similar to boron, aluminium, and silicon. So they were known as Eka-boron, Eka-aluminium, and Eka-silicon. But later these were named as scandium, gallium, and germanium. Even when noble gases were discovered later, they were predicted by Mendeleev's periodic table without disturbing the positions of the other elements. He kept spaces for these elements also. Okay. Now, incorrect atomic masses corrected. He gave a more focus to the similarities in properties rather than to atomic masses. Okay. So what happened? He gave he focused on similarities in the properties rather than on the atomic masses. So while arranging the elements, that led to the correction of the atomic masses of various chemical elements like gold, platinum. So atomic masses were corrected that time by focusing mainly on the properties rather than the atomic masses. Now, what were the defects of Mendeleev's periodic table? First is anomalous pairs. The following pairs of elements don't follow the Mendeleev's principles. Okay. Argon with atomic masses 39.9 is kept before than potassium with atomic mass of 39.1. So argon should come after potassium, no? But argon is placed with atomic mass 39.9 before potassium. Cobalt with a higher atomic mass precedes nickel. Nickel is having 58.6 atomic mass, and cobalt is having 58.9, but still cobalt is placed before than nickel. Then tellurium. Tellurium is 1 at 27.6. Again, it comes first, then 1 to 26.9, that is iodine. Okay, so this is anomalous pair. Okay, this is anomalous pair, which is a defect of the Mendeleev's principles or Mendeleev's table. Now, grouping of chemically dissimilar elements. Elements like copper and silver bear no resemblance with the alkali metals. They do not resemble the alkali metals, but they have been placed together in the first group. They do not resemble the alkali metals, copper, silver, but still they are placed in the first group. Then Position of isotopes. According to Mendeleev's periodic law, isotopes of an element must be given separate places in the periodic table. So according to Mendeleev's law, periodic law, the isotopes should have a separate place in the periodic table because they have different atomic masses which were not assigned. Okay. Then electronic arrangement. It does not explain the electronic arrangement of the elements. Okay, it does not explain how the elements were electronically arranged. Then separation of the chemically similar elements. Chemically similar elements like gold and platinum, they were separated in different groups. Dissimilar elements were placed in the same group. Okay, these were the defects of Mendeleev's table. Anomalous pairs. The atomic mass which is having a more, the elements which is having more atomic mass is preceding the element which is having lower atomic mass. Okay, then position of hydrogen. Hydrogen was not given a fixed position and was considered in group 1A, as well as also it is found in group 7A because it forms both a positive ion, example with forming HCl, and a negative ion as sodium hydride. That's why in both the groups they are found. So hydrogen is not getting any position according to Mendeleev's periodic table. So these are the defects which are found in Mendeleev's periodic table. Okay. Now, atomic number as basis for modern periodic law. After assuming that there are errors in the atomic masses, okay, after assumed that there are many errors that are found in the atomic masses, Mendeleev placed certain elements not in order of the increasing atomic mass to fit into the proper groups of his periodic table, but he used similar properties. For example, argon was put in front of potassium. So atomic mass, he did not consider the atomic mass, he considered the properties. Okay. Then elements were not placed into groups that express similar chemical behavior. The magnitude of positive charge present in the nucleus of an atom was determined. This for the so atomic masses were not considered according to Mendeleev. Then Henry G.J. Moseley, he was an English physicist. He found that the nucleus of an atom had the magnitude positive charge. Okay, in 1913, he used anodes of different metals in a discharge tube and subjected them to attack by cathode rays. Okay, he used anodes of different metals and they are subjected to attack by cathode rays. He found that when cathode rays struck the anodes of different metals, the wavelengths of these rays decreased in regular manner on changing the metal of the anode in order of their position in the periodic table. So what happened? I told you he used a different, this Moseley, Henry Moseley, he used different anodes. Okay, different anodes are used and, different metals used as anode, and cathode rays were falling on these anodes. Now, as he changed these metals, he found their wavelengths of the cathode rays which struck the different metals that decreased in regular manner on changing the metals which were in order of their position in the periodic table. So he concluded that the atomic number of an element is more fundamental property than its atomic mass. Now, with Moseley's contribution, the periodic law can be restated as like this. Similar properties recur periodically when elements are arranged according to their increasing atomic number. Not to atomic mass, but atomic number. Okay. Now, atomic number of an element, what is atomic number? Is the number of unit positive charge or number of protons which is present in the nucleus of an atom of that particular element. So what happened after Moseley's discovery? Modern periodic law came into existence. Now, what did modern periodic law state? The physical and the chemical properties of the elements are the periodic functions of the atomic numbers, of their atomic numbers. They're the periodic functions of their atomic numbers. Now, if elements are arranged in order of their increasing atomic number, those with similar properties are repeated after regular intervals. That is, the periodicity in the periodic table occurs based on the atomic numbers, or you can say the number of protons. So periodicity can be based, this occur, periodicity of the elements in the periodic table will occur at regular intervals. This happens, that is based on the atomic numbers or the number of protons that is present in the element. Okay, so the physical and the chemical properties of the elements are the periodic functions of their atomic numbers. Okay. Now, what is the explanation of the anomalies which is found in Mendelev's table, or rather classification? It is the position of isotopes. I told you all the isotopes should have the same separate place, he told. Having the same number of protons have the same atomic numbers. So all isotopes having the same number of protons, we know they have the same number of protons, only the neutrons differ. So they have the same atomic numbers. Having the same number of protons, their atomic numbers will be same. Therefore, they can be put in the same position of the periodic table. That's why it is an anomaly in Mendelev's classification. Right? Now, he told position of the anomalous pairs. Okay. That is the atomic number, sorry, not the atomic number. It's an atomic number of argon is 80 and mass number is 40, and atomic number of potassium is 19 and mass number is 39. So according to modern periodic law, elements are arranged in the increasing order of their atomic numbers. And argon with lower atomic number should be first, and potassium with higher atomic number should be later. But he did not mention this one, no. Atomic number he did not mention. He told that he showed that atomic mass of argon is less, it's more than the potassium, but still it is coming first than the potassium, which is having the less atomic number. Atomic mass. Okay, but actually it is, according to modern periodic law, we can see that argon has lower atomic number. That's why it is coming first than potassium, which is having a higher atomic number. Like this, the position of cobalt and nickel can also be justified. Okay. So this much for today. We will start with the modern periodic law, and whatever rest is left behind, we'll discuss that. So till then, please do revise. Please do comment if you have any doubt in your video. If you find any doubt in your the videos, and if you have any question, you can also write it there. You can also access my email ID, that is Kasturi, Kasturi, Kasturi74@gmail.com. Please do write there. And if you are liking the videos, press the like button, share with your friends so that they can also be benefited from these videos. And if you have not subscribed yet or a new viewer to my channel, please do subscribe. Okay. And ring the notification bell, because that will notify you as soon as a new video is uploaded. Okay. So thank you for joining, and please do meditate before you start your day. Thank you.